Hi everybody, it's really a pleasure to be here. I'm Sara Ricciardi, Senior Researcher at INAF, the Italian National Institute for Astrophysics, and member of the OAE Center Italy. And today I'm presenting on behalf of one of my colleagues at INAF, Fabrizio, and some teachers in Bologna, Marilisa, Stefano, Adele, and Antonia. So this work is grounded in the idea that in the contemporary society shaped by science and technology, education must help pupils understand how knowledge is constructed, not only what we know, but also how we come to know it. Developing a scientific citizenship is in fact a matter of democracy. If we want all citizens to participate in the conversation that shape our collective future, then everyone should have access to the language, the practice, and the value of science. This is why we choose to work within the public school system, because public education is where the question of equity and social justice are not abstract, but daily and concrete. Tinkering, as an informal and playful practice, offers a way to bridge curiosity and disciplinary inquiry. It allows children to do science, to construct and test their idea, much like scientists do, while keeping joy and creativity at the center of learning. The challenge, however, is how to embed such an informal and open-ended practice meaningfully within the formal structure of schooling, and this is precisely the question that guided our work. To set up a tinkering experience, we need to think at least to those four aspects. Those are not easy to implement, especially in the school environment. Focus exploration, purposeful play, learner choice, collaborative learning. All those aspects are connected with creativity. In most of the school I work with, when tinkering is present, it is usually not connected with disciplinary learning. It often stands as something separate, an enrichment activity associated with the 21st century skill, or creativity, something that is valuable, yes, but is perceived as somehow peripheral respect to the core of the curriculum, the core of school. In this challenge, we want to explore something different, how tinkering as an informal and playful practice can actually bridge curiosity and disciplinary inquiry, allowing children to construct science as a scientist do. This is the Canva we are thinking about. This way the teacher becomes facilitator, guide, and researcher, designing the educational experience. The wavy line illustrates classroom life. Tinkering workshop with their open and exploratory nature generate a cloud of relevant questions that then can evolve into disciplinary inquiry. Teacher guide the process by helping the selection of meaningful themes and supporting further exploration, while maintaining a balance between true open-ended discovery and structured knowledge building. So this is actually our implementation. We run this tight canvas on using the Light Play workshop designed by the Tinkering Studio in parallel with three fourth grade class in Bologna. Here we are presenting the work done in just one of those three schools. We work at Primaria Giovanni Falcone in Funo del Gelato. It actually is a small school within the countryside of Bologna. We did 4 tinkering sessions, 8 hands-on sessions, let's call it like that, 3 fishbowl sessions. There actually are some sessions in which we discuss with teachers some excerpt of the documentation, generally the video documentation. We got, of course, video documentation. We got the Journal of Light that I will talk about in a minute. One final question and answer, and some final questionnaire, and also student micro interview and some interview with teachers. And it was from the end of February 2025 to the end of school. That is the beginning of June 2025. So we set up material tables for tinkering that make it easier to predict the research question that might engage the children. For example, why generally a table for light play might include opaque material that create patterns, transparent material, colored material that produce splashes of color, and reflective material. In this case, we designed the first tinkering experience using only opaque material and provided the children with just one light source. Then on the second table, we introduced a second light, for example, because we were thinking, okay, then they will focus maybe on the penumbras and then we add the acrylics and so on. So this was a way to, somehow predict the research question and also to make it easier for teacher to develop the disciplinary thinking. This is how the tinkering session were, like, in a dark room in the school, and our table of material, our setting. Then after the tinkering session, which always include an immediate hot debrief about the session itself, there was also a cold debrief session. In this second moment, the experience is revisited from an emotional and social perspective. We ask them how they feel it, what kind of feeling they have during the tinkering, and also but we ask also about their research question, collecting using a wall map. So we asked them, if you were a researcher, what kind of question you will wonder about? So it was a little bit more also about their identity as a researcher. And this is the setting of our cold brief. So it's in their classroom, like they got post-it, they can write it down, and then we discuss it together. And this is where we are in the Canva. So after the tinkering, just exploding this idea space, all the idea about all the question they had about light and shadow, but also so many other things. So it was not just about that. And then this is, for example, one of the pages of our Journal of Life, Journal of Light. So after the tinkering session, we didn't propose an experiment already made, but we asked them to think and design their own experiment. So we provide material similar to the one used in the tinkering, but switching the scope. So in this case, they have, for example, 2 flashlights, some object, and a screen. And of course, they begin to investigate hard and soft shadow. This is the setting for our disciplinary work. And those are some of, their work. Modeling and thinking about these the things that they see. And so this is, for example, where we are. We iterated, we reach a table of material for tinkering, different prompts for experimental work, drawing from the research question. From a preliminary analysis of our documentation, we came up with a lot of research questions to refine. The first one is, can this approach stimulate the emergence of authentic scientific questions in young learners? But then we can also investigate scientific vocabulary and discourse, their ability of making hypotheses and testing, and also their modeling, and their drawing model, and finally metacognitive reflection on pupil and also on teacher about their self-efficacy. What we did in our preliminary analysis to look at the research question after the 4th tinkering session and see if there is a change. So we read and coded the question, selecting at the end 4 macro categories. And then we see they change. So the orientation in the setting of the task at the beginning. So they ask what we can do with these objects scattered on the table, why I have to build an object. Then they move questioning about the artifact, addressing aesthetic, functional, or interpretative aspects. So, for example, how could the tornado look realistic? Then they ask questions related to scientific and technological aspects observed during the activity. For example, why, when we mixed blue and pink, did it make a light purple, but red and blue make a darker one? And then finally, conceptual formalization and modeling, question, reflection, and hypothesis, in which pupils attempt to formalize or model the observed phenomena. For example, how do red, blue, and green lights make the color that appear, like cyan, violet, and yellow? Or, for example, how white is formed by combining red, green, and blue light. All these kind of questions. And finally, also, they start to interact within each other. Like, for example, one kids ask why when you combine a gel or any color with a red one, does the red prevail? And then one of the kids answer, because it's darker, and another one adds, it depends on the type of gel. So they really change their perspective, and they feel they were able to also to answer back to some of those questions by themselves. So to conclude, what we observed is that tinkering can truly act as a bridge between pupils, world, and science. It creates a joyful and democratic space for children to ask authentic questions and begin to reason scientifically. For us, the reflective cold brief allow both pupils and teachers to deepen their understanding, turning spontaneous wonder into conceptual insight. And in this sense, tinkering in public school becomes not just a pedagogical choice, but a way to make scientific thinking accessible to all, preparing the field for a more adult scientific citizenship. If you want to know more about it, I have here for you links to the work of Tinkering Studio at San Francisco Exploratorium and some stuff we did at INAF and the paper we just published about a precursor experiment we did in 2021. Thank you so much for having me here. In case you're interested, drop me a line. In the next 2 slides, I just put some bibliography for you. Thanks so much.